Hi there, welcome to another video for the AQA Linear GCSE Higher paper. In this I am doing the practice paper set 3 and the calculator paper. It's a 2-hour paper but should be done in well under an hour. Question 1. Vicky goes on a spa weekend. She uses a voucher for £200. How much more does she pay? So how much more does she pay? Not how much does she pay, how much more? So the offer is as follows. Pamper yourself with a spa weekend, normal cost £360, offer 30% off. So you want to work out 30% of 360. Okay, well 10% is 36, so 30% must be 3 times 36, or you could just multiply by 0.3 on your calculator to work out what 30% is. And you get 108, so it would be £108. So you'd get £108 off, so 360 take away 108 is equal to £252. Therefore, she must pay £52 more. And it's as simple as that. Alternatively, a quicker way, probably the way I like the best, and I'll write it down here, I will write the discounted cost, price would be, well, if you're getting 30% off, that's like multiplying by the percentage multiplier 0.70, so 0.70 multiplied by 360. In one move, that gives you the discounted price of £252, and therefore extra must be 252 take away 200, which is equal to £52. Simple as that. 4 marks, very straightforward 4 marks to start the paper off. Question 2. Here are 4 expressions. Show that when x is 1, the median has the same value as the mean. Well, let's write them out. X subtract 1 would therefore be 0. 4x would be 4. 2x plus 4, so 2 times 1 is 2 plus 4 is 6. And x squared plus 1 squared is 1, 1 plus 1 is 2. So x squared plus 1 would equal 2. So the first thing to do is to get a mark is to actually write down the numbers, and we've written down the numbers, then work out the median and the mean. So do the mean first, maybe the mean's the easiest, add them up, 0 plus 4 plus 6 plus 2, and divide by how many there are 4. So that would be 12 divided by 4, which is 3. And to get the median, remember you put them in order, so let's write them in order from smallest to biggest. So 0 first, then 2, and then 4, then 6. The median is the middle number. Well, there's no middle number here, but it must be the average of the 2 middle numbers. So the median must be 2 plus 4 over 2, which again is 6 over 2 is 3. And there you go for 5 marks. Therefore state mean equals median. Again, unbelievably easy start to this paper. These 4 marks and these 5 marks already give you 9 of the easiest marks you're ever going to get. Okay, here are the expressions again. Work out the value of x if the mode is 10. Okay, if the mode is 10, then 2 of them must be 10 because there are 4 numbers, and for one to be the mode, at least 2 of them must be 10. So state down that 2 at least must equal 10. Now the question is, can 2 equal 10, or which 2 are 10? Well, let's suppose x minus 1 was 10, and let's suppose 4x was 10. Can they both occur at the same time with the same x? In this case, x would be 11, and here that would not work in this case. So these two, let's just, for now, let's just say that one can't be true at the same time. Could this one be true? 2x plus 4. Could that be 10? Well, if x was 11 from the first one, then 2 times 11 is 22 plus 4 is 26. Again, that could not work out. Now the question then is, could x squared plus 1 equals 10? Well, here x is 11, and again this wouldn't work in this case either. So x minus 1 can't be the one that's 10. Right, you keep going through the motions here. If 4x was 10, then if we're assuming that one's true, then x must be 2.5. Does that work for this one? 2.5 minus 1 is not 10. 2 times 2.5 is 5. 5 plus 4 is not 10. And 2.5 squared plus 1 is not 10. So hence, this one can't be the one that's 10. Can this one be the one that's 10? 2x plus 4, can that be the one that's 10? Well, then x would have to be take away 4, x would have to be 3. Okay, 3 take away 1 is 2, it's not 10. 4 times 3 is 12, it's not 10. And 3 squared is 9 plus 1, though that is 10. So, for x is equal to 3, 2x plus 4 equals 10, and x squared plus 1 is equal to 10, hence the mode is 10. So x is 3 as our answer. Only way to do this one is to just assume that's 10, find out x is 11, can you get 10 with any of the others? No. Then try that one is 10, x is 2.5, try it with the others, can they be 10? No. Then try it with this and you'll find that x is 3 works, not with that one, but also with that one. Hence, for x is 3, you would get 10 and 10, and hence this would be the mode. Okay, next question. 3a plus b is equal to 2. Work out 2 possible pairs of values for a and b. Well, I mean, this really is quite simple. If you chose, let's say, a to be 1, then 3a would be 3. What would you need here to get 2? Well, b would have to be negative 1. So a could be 1 and b could be negative 1, for example. What else could we do? We could, let's just say a is 2, let's say. A is 2. 3a would be 6. What needs to be here to get 2? Negative 4. So a is 2, b is negative 4. I mean, there are infinitely many answers here. You know, it's just a case of trying out a few. Very easy. Next question. The table shows the probabilities of a team winning, losing or drawing a match. The probability of winning is P. The probability of losing is 2P. The probability of a draw is 0.1. Work out P, the probability of winning a match. Well, you know that probabilities must add to 1, right? So P plus 2P plus 0.1 must add to 1. The probability of all the outcomes must add to 1. So you have 3p plus 0.1 is equal to 1. This is some algebra now. Subtract 0.1. 3p must be 0.9. Divide by 3. P therefore must be equal to 0.3. Double check it works. If that was 0.3, 2p would be 0.6. Do they add up to 1? Yes, indeed they do. So p is equal to 0.3. Again, very easy. Question 4. Dots are joined by straight lines to make a sequence of patterns. Complete this pattern. So you join each dot to each other dot, in the case here. So here you would do the same thing, but every dot must be joined to every other dot. So it would be something like that. Okay. Right, that's 1 mark. Let L be the number of lines and D be the number of dots. One of these formulas works for all patterns in the sequence. Which one is it? Show your working. Okay. Firstly, what we could do is we could have a table here with lines and dots from the working we've done. So let's have a table with lines, dots, and maybe, actually we could do it this way, lines and dots, and then in each one here we could, so in the first case we have 1 line, 2 dots. In the second case here we have 3 lines and 3 dots. In the next case here we have 4 dots and 1, 2, 3, 4, 1, 2, 2 lines, 6 lines, sorry. So we've got 6 lines and 4 dots. And in the last case, we must have 5 dots. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10. 10 lines. So the question is, which of these formulas work for each one? So firstly, we could spot that they the lines are going up in 2, 3, and 4. So it's certainly not a linear sequence. It wouldn't be a linear sequence, so it's definitely not that one. It's either one of these two, and then we've just got to check which one it is. Let's pick this one here. 4 times 5 over 2 would be 10, so that doesn't work. Would this work? 4 times 3 over 2 would be 6, and that works. So it must be formula 3. Okay, and I suppose you should just show you checked it. So let's say check D equals 4. So L is 4 times 4 minus 3, 4 minus 1 over 2, which is indeed 6, and it's correct. So to get the 3 marks, you've got to have a table summarising your answers, check one of them, and then state which formula works. Out of interest, I just want to show you why this works. This is a bit of A-level maths, just for those interested. Let's just look back at the picture here. Why does that one work? Why? I'm just going to draw this in a bit neater. Why does the formula connecting the dots at L is D minus 1 over 2 actually work? Well, let's think by looking at this hardest case here. Let's pick one corner, right? How many lines come out of that corner? Well, 1 does, 2 does, 3 does, and 4 does. Okay, so there are 4 lines come out of it. So say in this case there are 1, 2, 3, 4, 5 dots. Okay, from each dot comes out 1 less line. So there are D minus 1 lines coming out of it. If there are D dots, then there are 1 less line. Okay, so there are D minus 1 lines. Now, imagine you did that for each corner. You did it to this corner, this corner, this corner, this corner, and this corner. You would do it however many dot times. So you would times that by D. If you did it for all the dots, you would have double counted everything twice, because when you were counting from here, you would have counted that again, and then you would have counted all the different ones. So everything has been double counted, so you half it. Hence, that's where it comes from. Now, this is not important for this exam at all. Ignore it if you don't understand what I said. Some of you might like the fact where that formula comes from. Okay, use the correct formula to work out L when D is 10. Remember, L is D minus 1 over 2, so therefore L must be 10 multiplied by 9 over 2, which is simply 45, 90 over 2. Unbelievably simple. Even if you're stuck on this one here, attempt it with whatever formula you thought was correct. Okay, reflect the triangle in the line y is 2. You want the line y equals 2, for example, x0, y2, x1, y2, 2, 2, etc. Draw a few just to remind you which way the line's going. That's the line y is 2. Reflect it, that stays there. This is 2 away, that goes there. That is 2 away, that goes there. Reflection, simple as that. You use a ruler. Easy, easy, easy. Translate the triangle by this vector. That means 3 left and 2 down. Pick a corner. 1, 2, 3 left, 1, 2 down. That corner now goes there, so all the other corners can be joined. This corner's 2 up from it, this corner's 3 right of it, and there you go. Draw in with your ruler that triangle there. Simple as that. Okay, question 7. A plane flies 3,800 kilometers from London to Amman. The average speed is 80 kilometers an hour. It leaves London at 9 o'clock. What time does it arrive in Amman? So you need to know that speed is equal to distance over time, or from science, speed, distance, time, triangle. Sorry. Speed, distance, time, triangle. If you want to work out time, it's distance over speed, or rearrange this formula, time is distance over speed. So time is distance over speed, write down your formula. The distance is 3,800 divided by 800. Okay, so 3,800 divided by 800 is 4.75 hours, which in terms of hours and minutes is 4 hours, and 3/4 of an hour is 45 minutes. Okay, so if you leave at 9 o'clock, what time do you arrive? Well, 4 hours after that is 1:35, or on the 24-hour clock, 13:45. Change 800 kilometers to meters per second for 3 marks. So you're going at a speed of 800 kilometers per hour. Every hour. You're going 800 kilometers in every hour. So you want to go to meters per second. So how many meters is 800 kilometers? Well, it's 800,000 meters, isn't it? Because 1 kilometer is 1,000 meters. So it's 800,000 meters divided by 1 hour. Now you want to go to seconds. That's 800,000 divided by 1 hour. But how many seconds in an hour? Well, there are 60 seconds in a minute times 60 minutes an hour is 3,600. So you divide that by 3,600. So it's 800,000 divided by 3,600. And you get yourself 222.2 meters per second. Question 8. The cross-section of a building block is a trapezium. Calculate the volume. So the volume of a prism is the area of the surface times the depth. So let's work out the area of the trapezium. Area of trapezium. This is given in the formula booklet at the front. It's a half this distance plus this distance. That distance must be 6. It's the same as that. So it's a half 6 plus 12 multiplied by the height, which you're given as 7. Which type that in your calculator. So that is 0.5 times 18 times 7, which is 63 centimeters squared. So the volume must be this area, 63, multiplied by the depth, which is 90. You multiply those together, you get yourself 5,670 centimeters cubed. Underline your work. Done. Okay, question 8b. The block is made of concrete. 1 cubic centimetre of concrete weighs 2.5 grams. Calculate how much the building block weighs. Give your answer to the nearest kilogram. So, you want to work out the mass of a building block. 1 cubic centimetre, so 1 centimetre cubed, weighs 2.3 grams. Right? Now, you have yourself 5670, so you have yourself 5670 centimeters cubed. You want to work out how much that weighs. So multiply by 5760, multiply this by 5760. So 2.3 times 5760, 5670 times 2.3 is equal to 13,041. And they want it in nearest kilogram. That's grams, so this is 13 kilograms to the nearest kilogram. So the answer is 13. Do make sure you read the answer there. Okay, question 9. ABC is a triangular field. A fence is built from A to C. The fence costs £12.5 per metre. Work out the cost of the fence. Simple Pythagoras. We know that the hypotenuse squared, AC squared, must be the 2 shorter side squared, so 75 squared plus 38 squared. So i.e. 7069. So that is the length squared, so the actual length must be the square root of this, which is equal to about 84.077 meters. And then it costs 12.5 per metre, so 12.50 multiplied by 84.077. And you're getting yourself approximately 1,050 pounds 97p. Everything's been given in 2SF, so stick to 2SF. It would be 1050, let's say, to two significant figures. Okay, question 10. The interior angle of a regular polygon is 150. Write down the size of the exterior. The exterior is the angle, if you extended the side, what angle is that extension make with the outside of the shape? It's 30 degrees, so the answer is simply 30 degrees there. Work out the number of sides of the polygon. All exterior angles, exterior, add to 360. That's a rule you need to know. If each one's 30, then if you do 360 divided by 30, you would get yourself that there are 12 sides. There are 12 angles, 12 of these angles, therefore there's one angle per side, 12 sides. Question 11. Two ordinary fair six-sided dice are rolled together. The numbers are added to get the score. Two dice are rolled 300 times. How many times would you expect to see the score 11 or more? Okay, we're going to need a sample space diagram. However, you could just think, how do you get 11 or more? Well, actually, let's just draw a sample space diagram. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, or 6. So if you add them together, you get 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, 12, right? So what's the probability you score 11 or more? Well, that, and that. Okay, that's the chance of getting 11 or more. So therefore the probability of 11 or more is equal to 3 out of 36, which is 1/12. And how many times, if you roll it 300 times, how many times would you expect to get 11 or more? Well, 300 multiplied by 1/12 would be your expectation. And that would be 25 times. 25 times is what you'd expect. And when you're doing the sample space diagram, just label out dice 1, dice 2, for example. Okay, simple 4 marks. A, B, C and P, Q are similar triangles. Work out the value of x. So if they're similar, that side and that side are related to each other. So what's the scale factor? The scale factor must be 7 divided by 5, the bigger divided by the smaller, which is 1.4. Okay, therefore, this length here, 15 subtract x, that must be equal to 4 times 1.4. 4 times the scale factor, and 4 times 1.4 is 5.6. So 15 subtract x must be 5.6. So let's keep that working going over here. I think the easiest way to do these is to add x to both sides. So 15 would be x plus 5.6. Then take away the 5.6. X would therefore be 15. Take away 5.6, which would be 9.4. So x would be 9.4. Is that right? Double check you actually got the right answer. This length therefore would be 15, take away 9.4, which would be 5.6. And is 4 times the scale factor 1.4 5.6? Indeed it is. So you know you've done it right for 5 easy marks. Question 13. 30 students take a test, complete the cumulative frequency table. Cumulative frequency, cumulative means to add up the frequencies as you go along. There's been one frequency between 0 and 20. There's now been 4 between 0 and 40. There's now been, if you add these up, 10. There's then been 21 and there's been 30. Remember, this number, the n number in the cumulative frequency, must add up to the total frequency. Okay, draw a cumulative frequency diagram for the marks. So what you do for these ones, you always plot the upper bound against the cumulative frequency. Okay, so plot 20 against 1, 20 against 1, Then you plot 40 against 4, 40 against 4. Then you plot 60 against 10. And then you plot 80 against 21, plot 80 against 21. And then you plot 30 against 100. So you plot, 100 against 30. And that is your cumulative frequency there. Let's just draw a line between them. Okay, something like that. Take that away there. Okay, then draw a box plot for the marks. The lowest and the highest are plotted for you. For a box plot, you need the upper bound. You need the lower quartile, upper quartile, and median. Now there were 30 people, right? So the median happens at 15. Make sure you draw lines across for this. The median happens at 15. That's happening at about 70 marks. So 70 marks is our median. Okay. That's our median, label it M. Now the lower quartile happens at the quarter way along, and a quarter of 30 is 7.5, so it happens at about 7.5 about here. And the answer here seems to be about, I'd say about 52. So I would draw this one at 52. Here, and that's the lower quartile. And the next one happens at 22.5, which is about here. That gives me about 82 as the upper quartile, so 82 here. Draw in a rectangle as follows, and a little line between there and the smallest. And that is our box and whisker plot. Okay, for 4 quite straightforward marks. Quite important you actually label your upper quartile and lower quartile. The lower quartile we're therefore saying is 52. The median we're saying was 70. And the upper quartile we're saying is 82. Okay, label them in as well. Okay, Adam has £500. Beth has 130. Adam gives Beth some money. He now has twice as much money as Beth. What percentage of his money did he give away for 5 marks? When you don't know how much money was given away, etc., let's just use some algebra, right? It's easy to use algebra at this point. So, Adam has £500. He gives some money to Beth. So let X be money given to Beth. Okay, he had 500, and so now he's got 500 subtract X, right? But he knows that this is, he now has twice as much as Beth. Okay, now Beth has 130 plus X now, but now he has twice as much as her, so his amount is twice her amount, right? So let's solve for X then. 500 take away X must be 260 plus 2X. Let's subtract 260 off both sides. 240 subtract X would be 2X. Let's add X to both sides. 240 must be 3X. Let's divide both sides by 3. 80 must be X. So £80 he gave away. It asked what percentage of his money. The percentage he gave away was he gave 80 out of his 500 multiplied by 100. Okay, and you just type that in the calculator. 80 divided by 500 times 100 is 16%. So it's 16%. Solve this quadratic equation. Now, a couple of ways to do it. One, you spot it's a difference of 2 squares. It factorises to x plus 5, x subtract 5 is equal to 0. Therefore, x plus 5 is 0, or x minus 5 is 0. So x is negative 5 or x is equal to 5. So x is 5 or x is negative 5, right? Quadratic, factorising, spotting a difference of two squares. The other thing you might do is you might add 25 to both sides. Then you take square roots, so that's add 25 to both sides. Then you take square roots. When you take square roots, you get a positive and negative answer. So x is the positive square root of 25, which is positive 5, or x is the negative square root of 5. Hence you get the two answers you got before. Question 16, circle theorems question. O is the centre of a circle. Prove that the triangles AOB and COB, AOB, this one here, and COB, so this one here, are congruent. Now congruent means the same, exactly the same. So that means same angles, same sides, same lengths of sides. Okay, so we've got to show, we need to show that all the angles are equal and all the sides are the same. So if that's the centre of a circle, okay, that is the radius, r, and that must be a radius, so that must be r. And similarly, this here must be r, and this is r. Okay, so we have shown that they have two sides that are equal to r. So we could firstly state, well, that's enough for now. We'll come back to that in a second. Now let's use the circle theorem. That angle there, angle at centre, is always twice angle at end. So this whole angle here must be 50 degrees, right? Now, on top of that, because this is an isosceles triangle, these two angles must be the same, so that must be 25. Similarly, because this is isosceles, these two sides are the same, that, and you know that's 25, because the whole lot's 50, that must be 25, and similarly that must be 25, right? And what must this angle therefore be in here? Well, this angle in here must be 180 subtract 50, which is 130, and this here must be 130. So we have shown the following, therefore. How do we get our 6 marks? Firstly, let's state that this angle here ABO, the angle at B, is 25, and it's because it's isosceles. Okay? And therefore this angle here, AOB, must be 130 degrees. Okay, because it's 180, take away 25, take away 25. So basically I'm showing how I got those two angles there. Now, there are loads of ways to get this angle here. We got a different way, but we can now get the angle BOC. BOC must be equal to 360, take away 130, take away 100, which is equal to 130 degrees. So hence that's 130. And therefore, these two are isosceles. These two must be 25 as well. So OBC and OCB must be equal to 25 because they're isosceles and they have to add up to 180. Or we got a different way. We used angle at centre is double angle at edge. Okay, so what we have shown is we have shown that triangles OAB and OBC share two sides the same and the angle between, i.e. side angle side. So we've shown that this side and this side are the same and the angle in between is the same. That must mean they are congruent to each other. Question 17, work out x here. It's a right angle triangle. You're thinking Pythagoras or SOHCAHTOA. We're given an angle, so it must be SOHCAHTOA. Write down SOHCAHTOA. Label your triangle with reference to the angle. This angle here is the one you care about. This is opposite, don't label it. You don't want it and you haven't been given it. This is your adjacent, this is your hypotenuse. What has A and H? Well, K does, so highlight your K. That means cos of the angle is A divided by H. Let's substitute in. Cos of 30 must be A, which is your X, over H, which is 4. So therefore X must be 4 times cos 30. You tap that in your calculator and you get 3.46 centimetres. Question 18. PQ is a tangent to the circle. Give a reason why x plus 2y is 80. Now, if this is tangent to the circle, okay, the angle that a tangent makes with a chord, so this angle that this tangent here makes with this chord here, must be equal to the opposite angle in the shape that's formed. So 80 must equal x plus 2y by the alternate segment theorem. They're looking for those words, the alternate segment theorem. Okay, next question. Write down another equation in x and y. Well, similarly, just by given what we've just done, this angle here must equal this angle here, right? By this exact same rule, just going from the other side rather than this side. So x must be 65 minus y. So x must equal 65 minus y, right? Okay, solve the equations to get the values of x and y. Let's write our equations down. X plus 2y is equal to 80 and x is equal to 65 subtract y. Now, different ways of doing it. Notice you have x as the subject. So instead of writing x in equation 1, I could write this instead of x. So I could sub 2 in 1, and I would have, instead of x, I would have 65 minus y plus 2y is equal 80. Then I would have 65, negative y plus 2y plus y is 80, and y must be 80 subtract 65, which is 15. Subbing it back in here, let's say x is 65 minus 15, x would therefore be equal to 50. So x would be 50, y would be equal to 15. Okay, another way of doing it, just in case you don't like the substitution method, let's just have a look here. What you could do is you could rearrange this equation. You could add y to both sides, so you would have x plus y is equal to 65. There's equation 1, there's your equation 2. You could subtract the equations. Equation 1 subtract equation 2. 2y, x take away x is nothing. 2y take away y is 1y. 80 take away 65 is 15. There's your y is 15 again. Sub it back in to get your x. Okay, question 19. A bag contains 6 counters. The number of yellow counters in the bag is y. The counter is chosen. A counter is chosen at random from the bag and replaced. Show that the probability that the counter is not yellow is 6 subtract y over 6. Okay, so the probability of it being yellow is how many yellows are there? There are y divided by 6, right? So the probability that it's not yellow must be 1 subtract y over 6. Now, if you're trying to work this out, you can't subtract numbers and fractions until the bottom numbers are the same. 1 is really 1 over 1. So if you want to make this over 6, you multiply top and bottom by 6. 6 over 6 subtract y over 6, which actually is 6 subtract y over 6, as you were asked. Another counter is chosen at random from the bag and replaced. The probability that both counters are not yellow is y over 9. show that the following is true. Now, everything's replaced here. So basically, the probability that both counters are not yellow, well, the probability that the first counter is not yellow is this, 6 minus y over 6. And you multiply that by the same probability because the counters are replaced, and you're told that this equals 4/9, right? Sorry, that should have been a 6 again. Now, let's just multiply this out. If you're multiplying fractions, multiply top by top, bottom by bottom. So you would have on top 6 minus y, 6 minus y, all over 36 is equal to 4/9. Okay, what we might do then is we might multiply the top out. 6 times 6 is 36. 6 times negative y is minus 6y. Minus y times 6 is minus 6y. And minus y times minus y is plus y squared. All over 36 is equal to 4/9. Okay, tidying this up, maybe putting the y squared first and going over here, we'd have y squared subtract 12y plus 36 over 36 is equal to 4/9. Multiply both sides by 36. On your calculator, 4/9 times 36 is simply equal to 16. So y squared subtract 12y plus 36, multiplying both sides by 36 is equal to 16 as you were looking for. Take the 16 off both sides. Y squared subtract 12y plus 20 is equal to 0. Part C, hence show that the number of yellow counters in the bag is 2. Let's solve. Y squared subtract 12y plus 20 is 0. Let's factorise. Two numbers that multiply to positive 20 and add up to negative 12. Okay, they must be both negative numbers. So I'm thinking y y subtract 2, y subtract 10 is 0. Therefore y is 2 or y is 10. Well, y can't be 10 because you were originally told the number of total counters in the bag is 6. So you ignore this one. Therefore, y equals 2 is your answer. Okay, and three more questions. Question 20, simplify the following fully. Please get this right. We've done this in the previous video. The answer for this is 8a4b12. Let me just show you why again. That means 2ab cubed multiplied by 2ab cubed multiplied by 2ab cubed multiplied by 2ab cubed. Sorry, it's to the power of 4. My apologies. It should be 16. 2 times 2 times 2 times 2 is 16. A times A times A times A is a to the 4. B cubed times B cubed times B cubed times B cubed is B to the 12. Or you could think of it, if you want to, as everything gets raised to the power of 4. 2 to the power of 4, A to the power of 4, B cubed to the power of 4. 2 to the power of 4 is 16. A to the power of 4 is A to the 4. B cubed to the power of 4. Power of the power, you multiply them, you get the following. Please get those right. They're easy marks. Now, this question again, I love these questions. There's a very procedural way to them. When you see this once, it's the same each time. You want to make C the subject of the formula. C equals something. There's a C on top and a C on bottom. They're locked within a fraction. First things first, get the C from the bottom of the fraction. Multiply everything by C subtract E. By the way, put brackets around these so you don't make any silly mistakes with your algebra. So multiply everything by C minus E. You'll get F, C subtract E is equal to D subtract C. Now expand your brackets. This would be FC subtract FE is equal to D subtract C. Now, if you want to make C the subject, bring C to one side. Bring C to the, let's say, the left-hand side. So if we did these operations, say we added C to both sides to get C on the other side, and say if we added FE to both sides to remove that negative FE, would you agree with me that you would still have the FC, you would have plus C, because you've added C to both sides, and you would have that as equal to D plus FE, right? Now a C, this is the step you always then do with these. You factorise out a C. C gets factorised out, so FC divided by C is F, C divided by C is 1, so you get the following. And last step, you divide by the F plus 1 in the brackets, so C is equal to D plus FE all over F plus 1. Okay, simple as that. It's quite a straightforward procedure, it's always the same. Try and learn that and get that right in the exam. Lots of kids will struggle. It's an easy one to pick up some good A-star marks. Okay, the next question. A crane can lift a maximum load of 1,400 kilograms to two significant figures. Containers weigh 80 kilograms to one significant figure. Work out the maximum number of containers that a crane can safely lift. And the key word there is sort of safely. First thing, you know this is an upper and lower bounds question. So talk about the crane's lift first. Okay, two significant figures means that the accuracy you're measuring is the second significant figure. The first significant figure is thousands, the second is in the hundreds column. Therefore, the accuracy is to the nearest 100 kilograms. So the upper bound of this amount, you halve your accuracy and you add it on, 1450. And the lower bound, you halve your accuracy and subtract it, 1350. That's telling me that a crane can lift between 1350 and 1450 kilograms because I've measured it to the nearest 100 kilograms. Anything in between there would round to 1,400 kilograms. Let's now deal with the container. Well, it's one significant figure, so it's the tens you care about. It's the accuracy is 10 kilograms. So the upper bound, you halve the 10 and add it on, it'd be 85 kilograms. And you halve the 10 and you subtract it for the lower bound, 75 kilograms. Now, imagine you were the foreman in a yard where people are working, and you've got a crane. What would you be happy for absolute safety that the maximum number of cranes, containers you could put on a crane? So the maximum containers that you would put on a crane. Well, in a worst case scenario, let's assume the crane was only strong enough to lift 1350 kilograms, because you would want to take the crane at its weakest divided by the number of containers at their very heaviest, and you would not want to compromise or go above that number. So 1350 divided by 85 is 15 and 15.8. You wouldn't want you can't have 15.8 containers, so you would go to 15 containers. For safety, 15 is the maximum you would risk, because you would assume the crane was as weak as it could possibly be based on your measurements, and you would assume that the cranes are that the containers are as heavy as they could possibly be based on your measurements. You would do the it should have been this one here, and you would do the 1350 divided by 85. You get 15.8, but you would round down to 15 there, because that would be the maximum you would risk for safety purposes. Okay, and that's the end of this video. Hope you found it useful.